Hello students. So today in this video we will discuss how you use Newton laws of motion on particle or object. So before start this video, I assume all you know about Newton laws of motion, and we know Newton gave three laws, that is Newton first law, Newton second law and Newton third law, that we all know. Now in this video our main discussion will be this: how you use Newton laws of motion on object. Okay, so mainly Newton referred to the particle, okay, and it relate this Newton laws, okay, it relate the force acting on the object with mass and the acceleration of the object. But before applying or before attempting the equation on the body, you first or you should very clear which particle you are considering. So this is the main thing. So main thing is which particle you are considering. Which particle you are considering. Okay, this is the highlight thing. But in our practical field, we will deal extant body. You see, chair, table, our body, all are extant body. But we know this extant body will also made by a single particle, and this body is nothing but the collection of single particle. So if this single particle follow Newton laws of motion, then this extant body also follow the Newton laws of motion. But the main condition is each part of our extant body must have similar or must have same acceleration, both in magnitude and the direction. Okay, so the another highlight thing is in extant body, each part of the body must have same acceleration. Okay, now if this condition holds, then we can use the Newton laws of motion on extant body. Okay, now how you use the Newton laws of motion? For this there is a systemic algorithm, and if you know this algorithm, then problem solving and all the things will be very easy. So that's why we will learn in this video this systemic algorithm by step. Okay, so the first step is, this is our main task. We apply our Newton laws of motion on the particle. The main task is how we apply. This is our main work in this video. Okay, so the first step is step 1. Decide the system. This is main thing. Okay, decide the system. If you don't know the system, how you apply Newton laws of motion? So decide the system. So before deciding the system, you have to know what is system. Okay, so system is on which you will apply Newton laws of motion, or Newton laws of motion are to be applied on which body. Okay, so this is the system. So system is nothing but the on which, okay, Newton laws of motions are to be applied. This is our system, and the system may be a single particle, maybe extant body, maybe a block, maybe a block. Just this is a block, another block placed on this block. Maybe this is our system, maybe. Okay, or a string maybe also our system. Okay, or a block that is hanging from this string. This block maybe also be a system our. Okay, so the main restriction is of choosing system, that is each part of the system must have the identical acceleration both in magnitude and the direction. So this is main thing for choosing the system. The main thing is how the main thing is so the main restriction is of choosing the system is that each part of the system must have identical acceleration both in magnitude and in direction. Okay, so each part of the system must have identical acceleration, okay, both in magnitude and direction. Okay, if this condition does not hold, then we cannot treat this object as our system. This is the simple thing. Okay, now we consider a situation that justify this. Okay, so we will understand this thing by situation or by example. Okay, so see, so we will draw a diagram here. Okay, so this is a block, name is A, and another block B that is placed on the A. Okay, and this A is connected by a string to block C. This is block C, and this block also connected another string, and this string goes to the pulley. This is pulley. Okay, again this string go here, and a disc sliding over the string. Okay, and another block is here. This is A, B, C, D block, or you can see, or you can name this thing, this disc as D, and this is A, B, C, D, E block, and this thing, there is another pulley. Okay, and here is another block. Okay, and a person is pulling this block. Suppose a person is here, he is pulling this block by giving F force. Okay, so A, B, C, D, E, this is F, or you can name it G, because F is here, the force is here, and we denote the force as F. Okay, understand this thing? Now see this thing. Here all the strings are connected tightly. Okay, that means this string is tight, and this A and this C is not connected directly, but they are connected through this string. So if the string is tight, that means the distance covered by C in a given time, the distance is same the distance covered by A in this time. That means A and C cover the same distance in a given time. Or we can say that the acceleration of the A and the acceleration of the C is same both in magnitude and the direction. The acceleration in this direction. Okay, and as this B does not slide on the A, on the surface of the A, it is just placed there. That's why we can say that this B also the same acceleration by magnitude and direction. Okay, and now check C, G. So G also connected by this string, and as this string is tight, so we can say that the displacement of the G as much the displacement of C or A. So we can say that the acceleration of the G also the same acceleration of A and C in magnitude and direction, because G also the acceleration of the G in this direction. That is, if we treat this side X, so this is X direction. The acceleration of A, B, C and G have same acceleration in magnitude and direction. Okay, but if you see this block E. This block E magnitude, if you see this in order to magnitude, then magnitude is same. The acceleration of E and the acceleration of G in magnitude order it is same, but the direction is not same, na? The acceleration of the block E acting in downward, but the acceleration of G acting in x direction or horizontal line. Okay, that's why we cannot treat E and G as our system. Okay, so which object or which block can we treat as our system? We will write this thing. Okay, so our system A will be our system, B will be our system. Okay, individually they can our system. Individually it is possible to take D as our system, to take E as our system. But if we take this combine, then there is that restriction. Okay, so if we treat A as our system, it is possible. If we treat B as our system, it is possible. If we treat C as our system, it is possible. Okay, if we take D, it is possible. If we take E as our system, it is possible. If we take G as our system individually, then it is possible. But if we take E plus G as our system, then it is not possible. Why it is not possible? Because their acceleration is different, because we know acceleration is a vector quantity. Their magnitude is same, but the direction is different. That's why we cannot treat these two things as our system. But we can treat A plus B as our system, or A plus B plus C as our system, or B plus C as our system, or A plus B plus C plus G as our system, or A plus C plus G as our system. We can treat this as our system. Why? Because they have identical acceleration in magnitude and direction. But this thing E, G, they have not same acceleration, difference in direction. Okay, that's why we cannot take E plus G as our system. And this thing is just sliding on the string. That's why D and E have not the same acceleration. So we cannot take D plus E as our system also. So understand this thing, how we choose our system. So system is basically on which we apply Newton's laws of motion. So that is our system. Okay, and in this way we select our system. Okay, student. Now we will go the next step. So this is the first step, that is decide the system. So the next step is identify the forces. So this is first step, and the next step is identify the forces. Identify the forces. After choosing the system, we will identify the forces that acting on the system and make a list. Okay, so but remember, but you have to follow. The system may be exerted some forces, or some forces exerted by the system, but we should not include that one. We only include how many forces acting on the system. Okay, so forces acting on the system, we only include this force. Okay, but forces exerted by the system we will not include. We will not include. So this is the main thing. Okay, so suppose this is our system. Okay, so a force acting on the system like this, like this, like this. We only take these forces, but maybe this body will exert a force in this direction, will exert a force in this direction, But in our table, we will not list these forces because these forces exerted by the system. We will not list this thing. We only take which forces acting on the system. That is this. Okay? And we will understand this thing if we consider a situation here. See the situation. This is the situation. Suppose it is ground. Okay, it is ground. And a person is here. So this is the person. Okay, this is the leg of the person. Okay, don't laugh. My drawing is so bad. Okay, see, and this is the load that is balanced on his head. Okay, see this thing. So this is the person A and this is the load B. So if you see this thing, see this person presses the ground in this direction. Okay, clearly understand this thing. This person presses the ground downward by the leg, by his feet. Okay, and similarly, this ground will give a force that is acting upward. That is, we know, normal force. So ground also give a normal force in this direction. Okay, normal force on this person. Actually, on this person. Okay, so N1, and this person will also give the ground the same force, that is N1, and ground also give the same force, that is upward, in the upward direction, that is N1. Okay, the direction is different. Okay, now see, also earth or the ground will pull the person by gravitational force in this direction. Okay, that is, we know the weight of the person, and similarly this person will attract the earth towards him, that is in upward direction. So this is the gravitational force. Okay, that earth pulls this person, and similarly this person, Newton thought law, every action has its same but opposite reaction. Magnitude they are same, but direction wise they are different. Okay, so this force, okay, due to this person on the ground, okay, that is also gravitational force. Okay, now see the load. So this load presses this person a force downward, that is downward normal force in this direction. Similarly, the person give a push in upward direction to the load, okay, on the load in this way. So this is the normal 2. Okay, understand this thing. Again, similarly, the ground attract this load downward, that is the weight of the load in this direction. Okay, and similarly this load will attract the ground upward in this direction. So this is the gravitational force. Okay, so in our universe, so many forces acting in this universe, but should we include in our table all the forces? Okay, this is the question. Should we include all the forces? So the question is, so this is the case. Okay, this is a scenario. So the question is, should we include all the forces in our table? The answer is, we cannot get this answer, or we cannot give the answer. The answer is, we cannot give the answer. Okay, understand why? Not because we don't know the forces, or we don't know the characteristic of the forces. But the main reason is we have not specified our system. That's why it is very problematic situation to handle all these forces acting. Okay, so first specify our system, then we will know, or we will understand how many forces acting on the system. Then we make a table, or we should make a list, okay, on the forces acting on the on the system. Okay, so first our main or our first task will be first specify our system. Okay, so then we will identify the forces. Okay, so this is the scenario. The scenario, watch, this is the person, this is the ground, and this is the person, and this is the load. Okay, so if we treat this load as our system, so in first case 1, load is the system. See, now we have specified our system, but in first case we have not specified our system. That's how we got a very problematic situation. Okay, in this case, on that case. Okay, but now we just specify our system. Okay, so now load is our system. So now we make a table here. So this is our table. So which is our system? This is now load. So system, now force exerted by, forces exerted by, then value, okay, value of the force actually. Okay, then the nature of the force. Nature. Now see, so our system is load, and tell me, this is our load, this is our load, this is L. So how many forces acting on the load? First tell me. So if this is we draw this picture, so we draw a big picture. Okay, so this is the person and this is our load. See, this is our ground. So this ground pull this load. Okay, so forces exerted by the ground, or we can say earth. This earth pull the load downward. So this is force exerted by the earth. Now, which force? That is mg. The mass of the block or load is m. So value is mg, and mg is what? Weight. So this is acting in this direction. That is w prime. So this is weight. Okay, nothing but the mg. Now, see, we only take those force which acting on the system. Okay, remember this thing. Again and again I am telling, we only take those force. Okay, now see, this person will also give a push, that is upward. So force exerted by the person, okay, that is, we know, normal force, that is upward, that is n. So n in this direction. Okay, this person, the head of the person, give a push of the load in the upward direction. So this is n prime, this is n prime. Okay, now, so we know the nature of the this force, that is gravitational force. Gravitational force. And this force is nothing but the electromagnetic force. Electromagnetic force. Okay, these are two forces that acting on the load. Understand? Tell me if there is any other forces that acting on the load. Tell me in my comment section. Okay. Now, and we know the direction. See, this force, that means this gravitational force by the earth acting downward. So it is acting downward. But this force, that normal force, acting upward by the person. So this is upward. Understand? Then we will proceed the next system, that is we will take the person as our system in next table. Okay, this thing understand? Okay, now we will take our system is now person. Okay, first tell me, this is the person. Okay, so okay, first who give the force on the person? This load and the earth. Okay, so first is earth. That is, we know earth pulls everything towards its center. That is weight of the person. So this is weight W. In which direction? That is downward direction. Okay, and see this ground also give a normal force or also give a push in upward direction, na? So again earth, okay, normal force, that is N, in upward direction. Okay, now see, other thing is this load presses down. Okay, give a force in downward, that is also normal force by the load on the person. Okay, so load, okay, load, normal force, that is N prime. Okay, and this is the gravitational force, this is the normal force, is the electromagnetic force, and this normal force by the load, it is also electromagnetic force. The direction is, this is downward, this normal force by the earth or ground, that is upward, and the normal force by the load, that is downward. Okay, understand all this thing? Then see, this is very easy now to identify the forces and to know the nature of the forces, because we have specified our system now. But then before we have not specified it. That's why the situation was very problematic to identify the forces. Understand? Now the main thing is step 3, that is free body diagram. Okay, the main thing is free body diagram. After drawing this free body diagram, this thing will be very easy. Again I am telling. Okay, that's why physics is interesting and mathematics more interesting. And we people just divide these two things, physics and mathematics. But in practically, if mathematics is not there, then physics also is not be there. These things are just, they live just each other. Okay, they are made for each other. Okay, this is the main thing. Now, the step 3. That is free body diagram. See, now up to this we specify, we already knew what is system, okay, and how we choose our system, okay, and then we identify the forces, okay, specify our system, okay. Now we will draw something new, okay, that is free body diagram, okay. So in this diagram we just choose our system as a point. So main thing is we choose our system as a point, okay. Understand? We just represent our system as a point, and vector and we will draw vector that represents the forces on the system, okay. So we will draw vectors that represent the forces on the system with point as our origin. See, first thing is we already choose our system, then now we represent our system as point and draw the vectors that represent the forces acting on the system or acting on the point, as our system now a point, okay. And these forces maybe lie in a plane, maybe lie only in a line, or maybe lie in a space that will be maybe in non-planar, but rarely this case we encounter this non-planar force. Maximum time we encounter forces in a line, forces in a plane, maximum time, okay. So what is free body diagram? Free body diagram is so indicating the magnitude of the forces and direction of the forces on the system, or the system is now a point, okay. So this is free body diagram, okay. So and the main thing just that I forgot to tell, that is we choose our system as a point now, na? And we will draw a separate diagram of this point, okay. Remember this thing. I will take some example that then you can understand more easy, okay, more easily, okay. See, so what is free body diagram? So indicating the magnitude and the direction of the forces on the system is free body diagram, okay. Understand? Now we will see, or we consider the scenario, or we take example here, okay. See, we take that example, that person and a load on his head, that example, okay. Understand this thing? Now we will go the next. So person, see hand of the person, this is the leg of the person on the ground and a load on his head. Now first we take this load as our system. So system, here load. And step 3 we already told, first represent our system as a point, then draw a separate diagram, okay. So This is our load, our system now. So we represent the system as a point. So this is our point. Actually, this is load. We represent the load as a point. Okay. Now we separate. This diagram will be separate from this diagram. Okay. Now we will see how many forces acting on this point. Okay. See, in the previous step in the table, you already know the forces that acting on the system. Okay. Here, if this is a load, then this person will give a push to the upward. That is normal force that is acting in this direction. That is N. Suppose N. This is N prime. Okay, so N prime acting in this direction. Sorry, N prime. Understand? And Earth attracting this load. That is weight of the load. That is in this direction. That is W prime. Okay, student. So this is our system load. Now our system is, see, this is our vector representation of forces. Okay, and the direction is this. Okay. Now the another system that we will take, that is person. See, the person is represented by a point. Also, we represent the person as a point. So this is a point. Now tell me, this ground give a upward push. That is normal force by the ground. That is in this direction. That is N. Okay. And now the earth will pull the person. That is the weight of the person by the earth. That is acting in this direction. W. Okay. This W prime, this is W, because this is the weight of the load, this is the weight of the person. Understand this thing? Now, this load also give a force downward, and that is the same, this N prime. So in this direction, so N prime act in this direction. So this is N prime. The whole thing is at rest and balanced. So from here we can say N prime equals to W prime, and from here we can say N equals to N prime plus W, or N equals to W prime W. Understand what is W? W prime, that is the mass of the load is M, that is M. G, the mass of the person is M, that is mg. So G common, M plus M. That is basically the equation. Now in the next step, we will understand how we take our axis and how we use the equation, or how you write the equations. Okay. So this is step 3. Understand, student? Okay. So step 3 is, so step 4 this is, okay. Now choose axis and write equation. Okay. Now see, any 3 mutually perpendicular direction we can treat as our 3 axes. Okay, and this axes are mutually perpendicular. So this is our axis. Suppose this is 3 direction, that is mutually perpendicular. This is, we can treat this x axis, this is y axis, this is z axis. So 90 degree angle, 90 degree angle, 90 degree angle. They are mutually perpendicular. Okay. And suppose if the forces are in a plane, then we only consider 2 axes, that is either xy or yz. That is your choice. So suppose the forces lies in a plane, then we can choose two axes. Okay, so if forces lie in a plane, then we choose two axes that is mutually perpendicular. Okay, see, one is x, then other is y, or this is x, this is x, this is y, no problem. This is y, this is x. Okay, if the forces lie in a plane. If the forces lie only in a line, then we can take just one axis, x, either x or y. Now we assume, okay, our particle or our system is known to have or likely to have acceleration in the x direction. So suppose in x direction, our system is known to have or likely to have acceleration, Okay, then the perpendicular axis will be the y-axis. Okay, now take this one. So we choose the x and y axis. Okay, so this is x, this is y. Okay, so many forces like they are in a plane like this. Okay, like angle theta, 1, theta 2. Okay, this is another one. So these forces. Okay, now see, so component of forces along x direction, remember or understand this thing. Component, this is suppose F1, this is F2, this is F3. Okay, so component of the forces along x direction, okay, equate their sum to the mass and the acceleration of the system. Okay, so the thing is, how you get the equation? So that is component forces along x direction. Okay, component forces along x direction and equate their mass equate their sum, okay, to the product of mass and acceleration of system. Understand? So suppose this is a force F1, this is force F2, this is F3. So all the forces have x component. So sum of all the x component of the forces, then equate their sum to the mass of the system, that to the product of the mass of the system. We know that force equals to mn. That's why this is the sum. This is the total force along x direction. So this is, we equate this sum to the product of the system and the acceleration of the system. So if the particle likely to move is known to have acceleration in the x direction. Now in y direction, similar, component forces along the y direction and equate their sum to 0, because the particle moves in x direction, or the acceleration in x direction only. Okay, we assume the particle moves in x direction. So component forces along y direction equate their sum to 0. Okay, so F net in y direction, okay, y direction equals to 0. Understand? In this way we got two equations. One equation, this is two equation. So and we know as many unknowns we got as many equations. So if the unknown is higher, so we need equation, that number of equation. So if require any object to choose our system, then we will choose this object as our system. If any necessary, okay, if any necessity, then we can choose it and follow this step. Understand this thing? So this is the total thing how you work, okay, Newton laws of motion on the system. Okay, this thing understand? Okay. Okay. Now we take a problem here, then we can understand this thing more precisely. Suppose this is a block. Understand this thing, okay? Suppose this is a block and the mass of the block is m, and a person is pulling this block, giving a force, and the angle between this force and with the horizontal line is theta. Okay, actually this is a string, this is actually a string, okay, or leave it, this is like this, or this is a person just pulling it, okay, no problem, this is a person is pulling it. The problem is a person is pulling this body, this block, with giving F force, and there is angle between this F force and the horizontal, that is theta. Okay. Now the question is find, and this block moves in x direction. Okay, moves in x direction. Okay, find tension in the string. In the string. This is one question. Another question is find the normal force. Find the normal force by ground on the block. So we will follow the free body diagram. Okay. So now we will take this mass, this block as our system. So this is our block. So we know na, in free body diagram we will represent our system as a point. So we represent our this block as a point. Okay. Now how many forces acting on the system? That is ground give a upward push, that is normal force, that is M. Okay, and this is a T. Okay, because we know na, tension acting away from this part. Okay, away from this block. So if this is T cos theta, and this is T sin theta. So T cos theta acting in this direction and T sin theta acting in this direction. Understand? Now weight that is acting downward, that is M into G. Okay, now tell me, now see, the particle moves in x direction, so we can write T, because we know na, component forces along the x direction. Tell me the component forces, or tell me the forces along the x direction. That is T cos theta, that is the component forces of T. Okay, so T cos theta equals to, we equate the sum of the component forces along the x direction, okay, to the product of the mass and the acceleration of the system. Okay, so this is the mass M and the acceleration is A. So T is ma divided by cos theta. So this is the tension. Okay, we use here the free body diagram concept, a systematic algorithm we use here. Okay, now another thing, now we take the component forces along the y direction and we equate the sum of the component forces along the y direction to the 0, because the body is not moving in y direction. That is why t sine theta plus n, that is acting upward, mg acting downward, that's why we treat as a minus mg equals to 0. So t sine theta, n equals to, so n equals to mg minus t sine theta. Okay, and you get the value of t, just put the value of t here.